Okay, sound is hello, a very good evening to everyone. So this is huh? Hello, hello, is it okay? చేసా సార్ ఇప్పుడు hello, a good evening to everyone. Okay, is it audible, sir? Okay. Just a minute, students, and I'm going to explain a very important topic today. So, a very good evening to everyone, and myself Chandra Prakash, Faculty of Chemistry, Ecet. This is Ask Engineering Academy, Dilsukhnagar. So, this institution especially designed in order to make the students, in order to crack all kind of exams, especially for technical streams, and this is Ask Engineering Academy. And now I am going to explain one of the very important topic, that is corrosion, which is an extension or continuation of last or previous topic, that is metallurgy. So today we are moving on to corrosion. After the completion of corrosion, we move on to the next topic, which has closely associated with this topic. And moving on to this topic, first of all, what are the contents? What are the contents are there in this topic? Now we are moving on to contents. First, corrosion. Definition of corrosion can be explained in this topic. Next, factors influencing the rate of corrosion. How the corrosion can be affected. How the corrosion or the rate of corrosion depends upon certain kind of factors. So it can be explained in this thing. And now, dry and wet theories of corrosion. Dry and wet theories of corrosion. What is meant by dry theory? What is meant by wet theory of corrosion? Next, composition cell. What is meant by composition cell? What is meant by stress cell? And what is meant by concentration cells? These are examples for the corrosion cells. The corrosion cells are generally classified into three types. Those are composition cell, stress cell, and concentration cell. And next, rusting of iron and its mechanism. What is meant by rusting? How the rusting can be taken place. So it can be studied in this. And prevention of corrosion. How the corrosion can be prevented. How we can stop the process or degradation of metal surfaces. Next, protective coatings. These are nothing but how the corrosion can be prevented by using special coatings. Now after that, it is cathodic protection. What is meant by cathodic protection? Especially in terms of prevention of corrosion. Paint. What are the paints and constituent of paints? Paint contains many constituents. What are those constituents? How those are involving in the prevention of corrosion can be studied here. Functions of constituents of paint. Paints contain many constituents. Each and every constituent has its own role. How the constituent of the paint plays an important role in prevention of corrosion as a protective coating or protective layer. So these are all about contents of corrosion. Now we are moving on to the topic corrosion. Corrosion, factors influencing the rate of corrosion. Now first, what is meant by corrosion? Definition of corrosion. So corrosion is a concept which is a continuation of metallurgy. In the metallurgy itself, we have studied what is meant by corrosion, but in this topic especially, we are completely focused on corrosion. So corrosion definition is the first and foremost thing. First, definition. Definition of corrosion. What is meant by corrosion? Corrosion is nothing but it is a process of degradation. It is a process of degradation or deterioration of metallic surfaces metallic surfaces when they are exposed to external environments. So now, what is meant by corrosion? Corrosion is nothing but it is the process of degradation or deterioration of metallic surfaces. So we have metals. So metallic surface sometimes undergoes certain kind of modification or changes when the metal is exposed to external atmospheric things. External atmosphere contains what? Moisture will be there, humidity will be there, air will be there, various amounts of gases also there, different types of pollutants are also there. So when the metallic surface comes in contact with certain kind of factors that plays very important role in the atmosphere, then a layer or a degradation or chemical change will happen. That degradation of metallic surface or breakdown of metallic surface upon exposing to external things. అంటే ఎప్పుడైతే మన మెటల్ సర్ఫేస్ని ఒక అట్మాస్ఫియర్లో పెట్టినప్పుడు అట్మాస్ఫియర్లో ఉన్నటువంటి హ్యూమిడిటీ కానీ తేమ గాలి వీటితో అది కాంటాక్ట్లోకి వచ్చినప్పుడు మెటాలిక్ సర్ఫేస్ యొక్క మార్ఫాలజీ షేప్ స్ట్రక్చర్ ఏదైతే ఉంటుందో అది చేంజ్ అయిపోతుంది. Such kind of phenomenon is called as corrosion. Corrosion is nothing but it is a process of degradation of metallic surface when it is exposed to certain kind of chemical environment. The chemical environments examples: heat, light, moisture and oxygen. These are the very important external agents. So these external agents will be influence the rate of corrosion. Now we are moving on to factors influencing the rate of corrosion. How the corrosion can be influenced and what are the factors in it. Now we are moving on to that. Now we are moving on to factors. What are the factors? What are the factors generally used? Factors affecting corrosion is first and foremost thing is temperature. Temperature and the rate of corrosion are always directly proportional to each other. That means if we raise the temperature of the environment or the metallic surface to be corroded, అంటే మెటాలిక్ సర్ఫేస్ ఏదైతే కరోజన్లో పార్టిసిపేట్ అవుతుందో అక్కడ మనం టెంపరేచర్స్ రైజ్ చేస్తే the rate of corrosion can be increased. That means the rate of corrosion can be increased by increasing of temperature. So that's why temperature directly proportional to rate of corrosion. This is a first factor. So temperature, based on the temperature, the rate of corrosion will be. That means the deterioration or degradation of metal can be enhanced, can be increased by rising of temperature of that particular metal. This is called as temperature factor. Second factor is humidity. What is meant by humidity? Humidity in the sense the amount of water vapor present in the atmosphere. This is atmosphere contains minute water like droplets. Watery substances will be there. They are called as water vapors. How much amount of water vapor that atmosphere contains is called as humidity. Based on the humidity also, the rate of corrosion usually influences. So humidity also directly proportional to rate of corrosion. As the amount of moisture content, as the amount of water vapor increases, the rate of corrosion also increases. So this is how humidity plays an important role in process of corrosion. And third one is pH. We know that. What is meant by pH? pH is nothing but amount of hydronium ion concentration. If you take any solution, for example lemon water, lemon contains what? Citric acid. So the lemon solution is always in acidic in nature because of presence of citric acid in it. So based on the presence of acidity and basicity, the pH value will be altered. So the rate of corrosion also depends on pH. Generally, the rate of corrosion is always high in acidic environments. Remember this. If you get a question regarding the relationship between pH and rate of corrosion, you must blindly remember that the rate of corrosion is always high when the solutions or the temperatures or the atmosphere or external surroundings are acidic in nature. pH, more acidity, more acidic conditions, more acidic conditions, more acidic conditions, more corrosion. More acidic condition, more corrosion. Next, fourth one is impurities. Impurities. For example, there are many types of metals. Some metals exist in pure form, some metals are in impure form because they are combined with other metals. So based on the presence of how much amount of impurity generally a metal contains, on that also the rate of corrosion will varies. So if the amount of impurity percentage is more, that means if the purity of metal decreases or impurity of the metal increases, see, once think properly, just focus on my words. Once, for example, this is the metal. If the purity of this metal decreases, the rate of corrosion increases. If similarly, if the impurity percentage of this metal increases, the rate of corrosion also increases. That means impurity directly proportional to rate of corrosion. Rate of corrosion. I think you might understand this concept, I think, very well. Impurities means unwanted substances or non-metallic species. And next, fifth one is stress. Fifth factor is stress. Stress in the sense, for example, this is a metal. If we apply lot of pressures or if we apply lot of temperatures or many kind of external parameters on this metal, it experiences certain amount of stress. Due to increase of stress levels, also the rate of corrosion of this metal increases. That means stress directly proportional to rate of corrosion. Rate of corrosion. Okay. Now see, now in this slide we have completed definition of corrosion, how the corrosion will usually happens, and what are the factors that significantly influences the rate of corrosion also we have clearly explained. In that we have discussed about temperature, humidity, pH, impurities and stress. These are the 5 important factors on which the corrosion usually depends. Now moving on to dry and wet theories of corrosion. What is meant by dry and wet theory of corrosion? Dry and wet theories. Now the phenomenon or the mechanism of corrosion can be best explained in 2 theories. One is dry theory and another one is wet theory. Now we are moving on to dry theory. Dry theory of corrosion. Dry theory of corrosion. Dry theory of corrosion in the sense, dry theory, in the name itself, dry theory. Dry in the sense there is no wet conditions, there is no moisture content in this case. That means the degradation of metallic surface happens only by exposing to atmospheric gases but not moisture content. That means in the absence of moisture, it is simply corrosion in the presence of air or atmosphere, in the presence of oxygen simply, for example for oxygen, but not in the presence of moisture, in the moisture content. Moisture. That means the corrosion, dry theory explains that it is a process of corrosion that usually happens when the metallic surface directly interacted with atmospheric gases, even in the absence of moisture or water vapor. So that is called as corrosion theory, which is also called as dry theory of corrosion. The best example for example, I will explain the mechanism with a simple equation, that is, this is metal. This metal surface is exposed to oxygen, atmospheric gas. So it forms as metal oxide layer. Metal oxide layer. It is a product of corrosion. Metal oxide layer. It usually happens at high temperatures. Happens at high temperature. Example, generally example for dye theories is tarnishes. Tarnish formation. Tarnish is a kind of rust. Tarnish formation on silver plates. Formation on silver plates. Silver plates. When you observe silver containing plates, where we are daily used in our home needs, on the silver certain amount of rust layer will be formed, that is called as tarnish. The tarnish formation is mainly due to exposure of silver to the atmospheric gases in the absence of moisture. So this is an example for dry theory of corrosion. The main thing you must remember during this concept is, in the absence of moisture, there is no moisture in this. There is no moisture, that is dry theory. If there is moisture along with air, that is called as wet theory. Simple. Wet theory. Now I am explaining wet theory. Wet theory of corrosion. Wet theory of corrosion means simply corrosion in the presence of moisture. In the presence of moisture. And this corrosion also happens at low temperature. It is at high temperatures, but in this case the corrosion generally happens or occurs at low temperatures. It is one of the advantage or disadvantages with this. And best example for the wet theory of corrosion is rusting of iron. Rusting. Example for wet theory of corrosion is rusting of iron. Rusting of iron. I think you might heard many times about this. Here in the case of rusting of iron, this is, for example, imagine this is an iron rod. When iron rod is placed in atmosphere, in the presence of water vapor, when this metal is exposed to atmospheric oxygen, a brownish or orangey colored layer will form, that is called as rust. Here rusting or corrosion of iron metal happening in the presence of both moisture and air. So this is called as rusting. In the case of rusting, water or water vapor acts as electrolyte. Water vapor acts as electrolyte. I will explain what is meant by electrolyte in the next chapter itself. Electrolyte. So this is all about dry and wet theories of corrosion. Now we are moving on to composition cell, stress cell and concentration cells. These are the three cells which are examples of corrosion cells. I will explain now. So these are called as corrosion cells. What are corrosion cells? I will explain you. Corrosion cells. Corrosion cells means corrosion cells are the specialized or specially designed cells where a favorable conditions are arranged for corrosions to happen. అంటే ఇది ఏంటంటే ఒక సెల్ లాగా ఉంటుంది, అక్కడ కర్రోజన్ ఎలా జరుగుతుంది అని మనం క్లియర్గా స్టడీ చేస్తూ ఉంటాం. సో దిస్ ఈజ్ ద ప్లేస్ వేర్ ద కర్రోజన్ విల్ హ్యాపెన్స్ 100%గా కర్రోజన్ అనే ప్రాసెస్ జరుగుతుంది. దానికి ఏం చేస్తాం మనం, వీఆర్ అప్లయింగ్ ఫేవరబుల్ కండిషన్స్, మాయిశ్చర్, ఎయిర్, టెంపరేచర్ అన్నీ కూడా మనం ఇస్తాం. సో దిస్ ఈజ్ కాల్డ్ యాజ్ కర్రోజన్ సెల్స్. కర్రోజన్ సెల్స్ కంటైన్స్ 4 important parts. Corrosion cell contains 4 important parts. One is cathodic site. Second one is anodic site. Third one is just a minute. Third one is ionic path. And fourth one is electron path. So these are the four components. These are the four components that corrosion cells is made up of. Four components. Now, based on these four components, the corrosion cells are again classified into three types. One is composition cell. Composition cell. Second one is stress cell. Third one is concentration cell. Concentration cell. And apart from these four, another cell is also there, that is called as galvanic cell. This galvanic cell is also called as composition cell. This is another name for this, composition cell. So galvanic cell is also called as composition cell. Now, what is mean by composition cell, what is mean by stress cell, and what is mean by composition cells, I am going to explain you now. Generally, what will happen in all these conditions is, in both concentration cells and stress cell, usually happens this. In this, for example, there is a certain kind of chamber like beaker like structure will be there. In this, two types of metals will be takes place. This is A metal and B metal. This is A and B metal. In this beaker, another electrolytic solution such as salt is taken, salt water or salt solution, salt. This is a concentration or corrosion cell chamber in which two different metals are taken and which are dipped in a solution containing salt, NaCl. So these two cells are in contact now, they are in contact in this solution. Now from this, the metal with more amount of corrosive property will be corroded first. Now see, these two metals are exposing to atmosphere. Simultaneously, it is also in the presence of electrolytic solution, that is moisture. In the presence of this, both the metals will be undergoes corrosion, but the metal with more corrosive property will be corroded first. For example, A greater than B. A corroded first because of A corroded first than B, because A is the more corrosive in nature. A is corrosive in nature. Corrosive in nature. So if these kind of things will happen, then this is called as composition cell, or it is also called as galvanic cell. And coming to the stress cell or concentration cell, here what will happen is, similarly stress cell or concentration cell, here same kind of apparatus will be take, two different metals are take, but these two different metals are placed in the different quantity of same solution. That means different concentration of same solution. For example, these are the two metals. For example, 50 ml of NaCl. They are dipped in 50 ml of NaCl. Now, same metals are placed in same solution, that is NaCl. Now 100 ml. 100 quantities are changed. That means metals are two different types of metals are placed in two different chambers. The only difference is concentrations of the solutions, electrolytic solutions what we have taken. In the first case we have taken 50 ml of NaCl, in the second case 100 ml of NaCl. If the corrosion cells in which the concentration is varying, that's why it is called as concentration cell. Because of that reason it is called as concentration cell. So this is all about composition cell, concentration cell, composition cell. Stress cell in the sense, some kind of impurities are added to create stress. To this beaker, some kind of impurities will be added. Impurities in order to get stress. So if the stress is added to the concentration cell, then that is called as stress cell. So this is all about corrosion cells. These are the four important parts of corrosion cells. These are the three important cells under corrosion cells. So this is all about corrosion cells. Now we are moving on to rusting of iron and its mechanism. What is meant by rusting of iron? Iron exposed to atmosphere, gases. If there is a moisture contained in the air, iron gets rusted. The rusting can be appeared in the form of orangish or brownish reddish colored layer. దట్ ఈస్ కాల్డ్ రస్ట్ అంటాం మనం. జంగు పట్టడం అని అంటూ ఉంటాం చూడండి, బ్రౌన్ కలర్లో ఉంటుంది, దాన్ని రస్టింగ్ అంటాం. అది ఎప్పుడు జరుగుతుంది? ఐరన్ అనేది అట్మాస్ఫియర్కి అందులో ఉన్న వాటర్ వేపర్తో ఇంటరాక్ట్ అయినప్పుడు ఈ లేయర్ ఫామ్ అవుతూ ఉంటుంది, దాన్ని రస్టింగ్ ఆఫ్ ఐరన్ అంటారు. సో రస్టింగ్ ఆఫ్ ఐరన్ ఇన్ ద సెన్స్ ఐరన్ comes in contact with, generally iron exists as Fe+2 ferrous form లో ఉంటుంది జనరల్గా ఐరన్. when it reacts with water or water vapor and reacts with O2 which is present in the atmosphere, see this iron which is usually in the form of ferric form Fe+2, this ferrous form reacts with water and O2 to gives rise to Fe3, now ferric oxide. Ferrous converts into ferric oxide. Now the exact mechanism here is, this is a chemical equation exact mechanism. Generally 4 moles of Fe+2 reacts with 3 moles of oxygen reacts with X amount of water molecules. See 4 moles of Fe+2 molecules, Fe iron atoms, 3 oxygen molecules, X we don't know any amount of water molecule, it will give rise to 2 moles of Fe2O3 ferric oxide plus again along with water. So rusting of iron in the sense, when this iron rod, when it is interacted with O2, interacted with water, a brown color or red color, simply this color, a brown color or red color layer will be formed like this. This is called as rust. This is nothing but Fe+3 from Fe+2 to Fe+3 convert అయిపోయింది. So this is what rusting, this is called as mechanism of rusting. So this is all about rusting of iron and its mechanism. Now we are moving on to prevention of rusting, prevention of corrosion or prevention of rusting. Simply prevention of corrosion can be definitely, so prevention of, we know that iron can be rusted, that is nothing but it's a corrosion, degradation of metal. How the rusting or corrosion can be prevented, how we can stop the process of corrosion, especially there are many ways, namely first is by applying protective coatings, by using inhibitors, the second one, and third by using cathodic protectors. Now by using technique called as alloying, and now paints, application of paints. So these are the 5 important things by which we can significantly reduce the process of corrosion or significantly minimize the rate of corrosion. So these are all about, this is how we can, corrosion phenomenon can be prevented. How these phenomena are generally employed, now we are going to move. First, protective coatings. Protecting coatings are generally classified into many types. For example, it contains paints. Paints are used as protective coatings to prevent corrosion. Epoxy resins, it is and again by coating the metals by surface with zinc coating, it is also called as galvanization, zinc coating. And next, barrier coating. So these are the different types of agents generally used to prevent corrosion, especially in the category of protective coatings. First, barrier coating. The function of barrier coating is, this barrier coating is nothing but it is a thin coating of metal with plastic like structures. Because of that coating, that the thin layer will be prevents the metal surface from exposure to air. అంటే ఆ మెటల్ సర్ఫేస్లో ఒక థిన్ లేయర్తో కోట్ చేసినప్పుడు ఈ థిన్ లేయర్ ఏమైతే యాక్ట్స్ యాజ్ బ్యారియర్, అది బయట ఉన్న అట్మాస్ఫియరిక్ కండిషన్స్తో మెటల్ సర్ఫేస్ ఎక్స్పోజ్ కాకుండా చేస్తుంది. సో ఇట్ ఈస్ కాల్డ్ యాజ్ థిన్ లేయర్ కోటింగ్. యూజ్ జనరలీ ప్లాస్టిక్ లైక్ థింగ్స్ విల్ బి హ్యాపెనింగ్ హియర్. యూజ్ హియర్ plastics. Now epoxy coating are good adhesions. it acts as good adhesives. Adhesives in the sense, when the epoxy resin, these kind of organic compounds, or whenever they are used, especially in combined with paints, it acts as good adhesives. Adhesives in the sense, when we apply paint to the metal surface to prevent corrosion, in order to stick on to the metallic surface, the metal surface ki stick ayi undali ante we have to add some kind of adhesives. They are called as gum-like structures or binders. So these epoxy resins are one such type of binders that increases the adhesive properties of paints. So this is what epoxy resins. Zinc coating is simple. Coating of metal surface with zinc layer is called as zinc coating. With the help of zinc coating, the corrosion can be reduced because it also acts as a barrier. Now paints are studied under special category. Now we are moving on to cathodic protection or paint. Along with the cathodic protection and paint, I will explain now. What is meant by cathodic protection? Cathodic protection means it is a process. Generally, during the cathodic protection property, this is also one of the process of reducing of corrosion. By this cathodic protection, we can minimize the rate of corrosion of the metallic surfaces. Metallic surfaces యొక్క corrosion property ని reduce చేయొచ్చు మనం ఈ cathodic protection వల్ల. How? In this process, especially, this is the, for example, this is the metal to be protected. అంటే మనకి ఏ corrosion నుండి ప్రొటెక్ట్ చేసే metal to be protected. This is A. Metal to be protected from corrosion is A metal. For example, this is A metal, which is the metal to be protected. మనం corrosion నుండి prevent చేయాలనుకుంటున్నాం. Now, it is combined with another metal, which is B metal. That is, it is B metal. That is sacrificial metal. This is called as sacrificial metal. A is the metal. We want A metal to be out of corrosion. This is a B metal, which is sacrificial metal. That means this is a metal actually corroded. It is corroded metal. Corrodes faster. Now, during this cathodic protection, what will happen? The metal to be protected converted into cathodes. The metal to be prevented can be converted into cathodes by placing these metals in electrochemical cells. See, this is the metal. In the cathodic protection process, this metal is dipped in electrochemical cells in order to convert this metal to cathode. That's why it is called as cathodic protection. Cathode. Now, this metal is also there in this because both metals are in combined state. Now, this metal is going to corrode it. Because of corrosion, some amount of electrons are released out. Because of corrosion, electrons are released out. These electrons are useful by this metal to prevent its corrosion. I think you might understand this. Cathodic protection means two metals are combined. One is metal to be protected from corrosion. Another metal is sacrificial metal, which is corroded faster. During corrosion, it gives some kind of electrons. These electrons are utilized by this metal to escape from the process of corrosion. Generally, this method is called as corrosion. All this phenomenon happens especially in electrochemical cells. They are specialized apparatus. So this is all about cathodic protection. Now, constituents of paint and functions of constituents of paint. Now we are moving on to paints. In the last slide, where I have already explained what are the different types of things which generally minimizes the corrosion. Among that, I have left with paint. What is paint? Paints are fall under the category of coatings. Generally, paint contains or constituents of paint. What are the constituents of paint? What are the composition of paints? Generally, paints includes different types of components. They includes pigments. These are the constituents or paints generally composed of. Binders, extenders, solvents and additives. 3, 4, 5. These are the 4 components generally a paint is made up of. First component is pigments, second binders, third extenders, fourth solvents and additives. So each and every component has specific role in preventing the corrosion from metallic preventing the metal from corrosion. So first, for example, pigments. Pigments are especially there to improve the metallic surface by enhancing a property called as opacity. It improvises the property of opacity. Opacity in the sense light interaction capability. This is called as opacity. Next, binders generally used for adhesions or addition. I already explained what is addition. It helps in the sticking of paints. Next, what are extenders? Extenders generally used for texture of paint. And paint thick undala, thin undala ane deni depend ayi untundi extenders. Extenders are agents that mainly show its impact in the texture of paint. The texture of paint will be depends on extenders. And solvents are generally used as thinners to reduce viscosity. Solvents are nothing but solvents are generally added in the paints because it is also one of the major constituent. This generally makes the paint more thinner, not thicker, by reducing its viscosity. Viscosity అనే ప్రాపర్టీని తగ్గించడం వల్ల పెయింట్ అనేది థిన్ అయిపోతుంది. థిన్ అవ్వడం వల్ల ఈజీగా మనం అప్లై చేయడానికి పాసిబుల్ అవుతుంది. దట్స్ వై సాల్వెంట్స్ ఆర్ ఆల్సో వెరీ ప్లేస్. Additive is generally used to enhance durability of paint, or it increases the shelf life of paint. To enhance the durability అంటే మనం ది పెయింట్ని లాంగ్ లాస్టింగ్గా వాడుకోవాలంటే ఇలాంటివి యాడ్ చేయాలి. దట్ ఈస్ కాల్డ్ as durability. This is called as durability of paint. Constituents of paint nothing but these 5 types, and each and every constituent has its own function. These are the functions. These are the constituents of paint. See, this is a previous year question, TS Ecet 2024-23. During electrochemical corrosion in acidic environment, I am saying acidic environment, generally hydrogen evolution takes place. Why? Because, for example, acidic environments, this is a electrochemical cell, these are the electrodes. When there is this is an electrolytic solution or aqueous solution, water. Simply remember that when there is an aqueous solution, when there is a corrosion, there the gas produced is hydrogen. So this is the answer. Hydrogen absorption will not take place, oxygen absorption not takes place, oxygen. So all 3 are wrong, but this is the right answer. Among the following metals which easily undergoes corrosion is, among this, sodium undergoes corrosion very easy because in the periodic table the sodium is a metal which is present in alkali metals. Sodium, magnesium, these are the 2 important metals which undergoes more amount of corrosion. So sodium is the more. Where silver, this aram gold, Cu copper, platinum, which are very hard, so they undergoes corrosion very slowly when compared with sodium. Which of the following is an example of cathodic coating? Simple cathodic coating. What is meant by cathodic coating? I think zinc coating and ferrous is an example for cathodic coating. Rate of corrosion increases with, see, I already explained what are the factors. Decreases the temperature? No. Temperature directly proportional to corrosion. Decreases of humidity? No. As a moisture or humidity increases, corrosion increases. Reactivity of metal, purity of the metal. Rate of corrosion increases with purity. This is the right answer. Reactivity of metal. How much reactivity, if the metal is more reactive to the atmospheric condition, there is more amount of corrosion. So this is the answer. Chemical formula of the rust is very easy. This is because after the completion of rusting, iron Fe+2 convert into iron Fe+2, that is Fe2O3 ferric oxide with water. I already explained this. So this is the answer. Now, which of the following does not corrode when exposed to air? Silver, no. See, Copper can get rusted, iron we know rusting, silver also rusted because this is called as tarnish. Aluminium, copper whites also gets rusted, but aluminium cannot be rusted. So this is the right answer. You all are wrong. Which metals from the following can provide cathodic protection to iron? Simply zinc and copper. This is the right answer. In the protection of iron structure by sacrificial anode, the metal used as anode is the metal used as anode. In the protection of iron structure by sacrificial anode method, the metal used as anode is simply zinc. So this is all about zinc. So this is all about corrosion, types of corrosion, what are the important things you might study, you will study, necessary to study or understand the concept in corrosion. Now we are moving on to another important topic, that is electrochemistry now. So before that, metallurgy and corrosion are not separate topics. They are the topics always stay together. Without understanding the metallurgy concepts, you can't understand the corrosion easily. So corrosion and metallurgy are always in closely associated topics. So please study metallurgy first and then go to corrosion. So you will get an idea about corrosion. So finally, myself Chandra Prakash, Faculty of Chemistry, thank you so much for listening my class very carefully and very patiently with utmost kind of concentration. And this is Ask Engineering Academy, Dilsukhnagar. And if you need any details in order to join any offline or online coaching for Ecet, Mset or NEET, you can directly contact to the details provided in the link box. Thank you so much once again for you students. And I will back with another fascinating topic, that is electrochemistry, within few minutes of time.